Hi there again. This is Hal, and this is not our project. I've actually gone here just for a minute to try and make another point. Something to do with that memory leak report thing. And that is this project, see? This again was sort of almost the original, and I've forgotten, but anyway, I went to compile it from the original form. You'll notice that a bunch of warnings showing up here. You see that? Now I know it's amazing, how much you can figure out just by, like, a friend of mine used to call it that thinking trick. That the thing you do when you do that thinking thing. He used to refer to this was my boss actually asking me to do something, and I would say, I'm not sure how to go about that, and that would be his answer. He would say, just do that thinking thing that you always do. But yeah, so using the thinking thing, I've just discovered, right? I must have forgotten that it is a 100% certainty that nobody prior to me had ever compiled this with this compiler. That is version 8 or whatever. 2000 Visual Studio 2005 is it's called VC8. I don't know what the actual version number is. It must be 8, right? 8.6. Okay. Anyway, and the reason I know that is because all these warnings are showing up. Now you see, it even tells you. All you gotta do is define, make this define, right? Just add this to the defines here, and all those warnings will disappear. Well, some of them did. Probably the wrong field. I'm pretty sure I just defined it. Well, this doesn't say that. Okay, this is something else. I see. Yeah, you can't get rid of this one with that memory defined. But I got rid of it. Oh no, I left it probably. Because I remember this kept bothering me. But still, which one? Well, anyway, what I wanted to show you is because if you look at this here, general, okay, they got this set on warning level 3. Now, let's say I just do this one. All right. Okay, now this is one of those ones that you could get rid of the warnings with too. That same directive. See? No warnings, everything's fine. Okay, so now they would have done that, and the reason I know that they would have done that is because it's set to warning level 3. See? Now, if you don't set it to warning level 3 for either of these projects. Suppose you went to warning level 4. Alright. This is going to be a little bit painful, but I just want you to see what it would look like if you compiled this, and I had to, and get it compiling. I didn't change this one, I only changed this one at warning level 4. Okay. Okay. How many we got so far? Still growing. Okay. Oh. No, I didn't change those to warning level 4. Those are just the test project. So which one is which? Just want to get a count here. Oh, I know. Why? I thought I defined that. Where is the number? You can see anyway, even without knowing what the number. Oh, here it is. 247 warnings. Okay. Now, so that's why they would have had it on warning level 3, because the warnings were annoying, right? So the only thing you can do when you got so many warnings like this, and that means that makes the warnings useless, because there's so many, you would never go through them all. The only option is to turn it back to warning level 3, right? And you saw at warning level 3, there were still lots of warnings. So therefore, using the thinking thing, I know that nobody had ever compiled it with this compiler. So now, there might actually be important warnings in here, but there's no way to get at them because there's too much data here for a person to process, right? If you hit F4, you're going to wind up on every single line of the program, pretty much, right? So that's what I mean about the overcrowding business with the warnings. Okay, going back to our world, we're at warning level 4, and we don't get any warnings. I was just thinking more about this memory stuff, and I happened to find this function for printing out the some information about the current running processes. I can't see all of them. Actually, I think this one I think is system idle or something. So some of them are private, I guess, or I don't have enough privileges or something or other. I just thought that because what I'm trying to do is I'm trying to get to this story that I want to tell. And I'm trying to think of a way to put it in the right context. And I thought of something, and my idea was, you see, what I want to do is set up a situation that, not equal to, but set up something that can give you an idea of this idea of multithreading. I don't know if you know the word or even the idea. Not every operating system has multiple threads. I don't know how to ask you if you know about threading or not. Windows is a multi-threaded operating system, and threads are things that happen, like I said before, it's like a little program inside a program. Okay. Now the bug had to do with something happening in one of these threads. And debugging a multi-threaded program is not like your regular type of debugging. It's a very strange mindset that you've got to get in order to try and understand what's going on, because you add in an extra dimension, sort of. You're looking at the same code, right? But you have to be trying to imagine that the code is simultaneously being executed independently with different sets of data in these separate threads, like processes. So I thought maybe I could make some threads. There's an interface to making threads. There's a function called CreateThread. See? And you would think, okay, easy enough. Call a function, right? Like any old function. Well, it's not quite as simple as just calling one function. You do have to set up a bunch of things first. Like you need to set up a stack size, and it's like making a new creating a program on the fly. And of course, you need to create a routine. This start routine, okay, that's like our entry point. So you need to make what they call usually a thread proc, okay, a thread process, which is where your little internal program runs within your program. Now, we've been writing these console programs, and pretty much there may be more than one thread. I doubt it, but let's see if there are. Like the system might have its own threads. You can check that here, see. I only see one thread going here, right? No. Now I don't believe that. Because this cursor is blinking, and this thing's not doing any, it's paused, it's not doing any cursor blinking. So what's causing this cursor to blink? I think there's some kind of, it's not showing everything here. Maybe there's a setting to like show all threads or something. This is not going to change. Wait, I know. If I could get it into a loop, just let it kind of, or just call it sleep. Sleep is a thing that stops the process. It's not stopping it from running, but it puts it into what they call a wait state for this many milliseconds, so 20 seconds. And then, while it's doing that, what I can do is, if I'm quick enough, break all. Did I get it? Deadlock. No, don't show me. I'm sure there's something doing this blinking, you know. Although maybe not. Anyway, let me see how much time I use. Okay, I got about 5 or 10 minutes. Now, what I'm going to do now, in order to get out of this main and dot world, I'm going to convert this program, get ready for it, into a Windows program. Alright? Now, I want you to pay very close attention. Maybe hit pause and go and get some pencil and paper and write all this information down as I go through the incredibly complicated, difficult process of switching to a Windows program without using the create new program thing here. Okay, are you ready? First, step 1. You go into here and you change this word here from console to Windows. Okay, that's part of it. Okay, now in system here, change this here where it says console to Windows. Okay, now are you getting all this? Okay, alright, now we're done. It's finished. Except, of course, we need an entry point. And that's called WinMain. And it takes certain, not that WinMain, WinMain. These are the parameters. Now, unfortunately, I don't have this set up with my secret thing in the commons, so we would have to call that directly. You know, I'd have to go. I'm going to do the init myself. But, anyway. Now, unresolved external main, reference to main. Oh, see, I gotta need a new init. Oh, yeah. Well, I don't need this anymore. We can use the default. Oh, but it's still an external. Still an external. Where do I do that? What I can do here, since this is no longer this is not used anymore, I can just say that should do it. That's the unresolved external. Alright, so now we've got a Windows program. And the only problem is it doesn't do anything. It doesn't do much. But we could put a message box. Message box. Not yet. Now, this will have to do for printf for now. Text, hello world, caption, some caption, and type. There's a bunch of defined types, but Can't remember. I know 0 is good. This will at least make our program do something. Okay. So now this is a Windows program. As you can see, there's just that. There's no console. There's nowhere for us to print anything. So if we want to print things out, one way we could do it, if we wanted to, is with the message box. And the problem with that is, well, for one, it's annoying, right? It's every time you want to see the next message, you got to click the OK button, and you're always clicking the OK button. It would be better if we could create a window, like a thing with a bunch of lines in it. So I secretly made a new function while you were while I was away, and where is it gone to? Hang on, I gotta find it. Okay, I found it. I invented this function here. It creates a window that we can put messages into using these special functions. One of them is called printf. Probably put %s there. This printf function takes this thing called a variable argument list, and put s here just takes a string, and it produces a character return. Now get here is a special thing that waits for a key to come in from the keyboard. I know this is weird stuff, but when I run the program, you'll understand. See, it printed out "Hello World," and now it's waiting for me to press a key. Now I press a key, the program quits. See? Pretty good, huh? And I created that window all by myself. Works great. Now if I don't have this sketch here, all that happens is that my window is going to disappear. No, that's no good. So that's why I got this. Now, the point is, I think you probably get the point. The point is, right, that there's no difference between a console program and a Windows program. They're one and the same thing, except that we may or may not choose to have a console. That's our choice. We want one or we don't. Nothing got passed in on the command line, so we didn't get our program name. However, it is possible to get such a thing. Do I have a function for that? Get process name or something? Oh, here it is. Get module found. Okay, so although we didn't get the that one in our argv list, we got this instead. Now, as far as the actually supplying a parameter, well, that's an unknown. The question is, if I type something like hello world, is that going to be the same as hello, with a bunch of spaces? Is it going to break that up into separate things? The answer, no. It doesn't parse it. It just gives it to us exactly as we had typed it in. Having quotes around should not get removed or anything. This one provides us with a little more information than the other one did. That is, it's not stripping away for our convenience this extra information. But I think we know a little bit about how to handle things like this, right? And how we might, in theory, maybe, be able to create a function called main, maybe, and call it, right? Sorry. Anyway. What I want to do then is, I want to create another window. I can't, well, I suppose I can make more than one of these consoles, right? But then, where does printf go? And which one reads from the keyboard? So it would be better to make just a Windows style window. I can still do that message box. Whatever it was. And but that doesn't help us at all in our pursuit of having two things going on at once, right? I can't, at this point now, I still can't type anything into here, right? And the cursor is blinking, so I guess that's the property of the console. So maybe it's not rolling. This is the same one in the same program, right? If I put that message box here, I hate when I do that. Where did it go? Right, it's only printed out part of the output, and then when I let it go, it does the rest. Okay, so now we're in the Windows world, and what I'd like to do in the Windows world is create something called a dialog log, right, rather than message box, which is a customized version of this, where you can make your own buttons and things, and you could also have things like list boxes where you can print strings into. And let me check my time again. And I thought as a good example of something for one of them to do anyway, would be to there you go. Oh, in the wrong directory. I have this animation. It was an animated GIF. I'll show you the animated GIF. And if you know this one, then you're an informed person. And but by the time I upload this, there should be by now an annotation showing up, directing you to a video describing this particular animated GIF. This here is the very first recorded animation by the human race, by mankind, this particular sequence of images. And it was created, in fact, in order to settle a bet. And how they did it, the reason why I call this recorded, was because this was done with photography. The idea of making an image appear to animate had existed already, and you could do with drawings, like you do in high school. In the corners of the pages of a book, you might make an animation. People had done that sort of thing before, but this is an actual recording of an actual horse and an actual person. Now it's repeating, right? It only goes for a few frames. In fact, because that looks like 15 maybe is the maximum. And the way they set it up This is kind of cute. You can't see it so much from the recording, but the way that they did it was they lined up a bunch of actual cameras, okay, and strings laid across where the horse would go by. And when the horse ran into the strings, it opened the shutters of the camera, which took a photograph of the horse as it was hit that string. And the burning question was, when a horse is galloping, do all the four legs leave the ground at any point? And the answer, as you can see, is that they do. And so there you go. The very first recorded animation by mankind. Now you know. Now you've seen it, and you'll if I manage to find that link anyway. You'll see on another channel that I have on YouTube, someone else discussing this. That other channel has some thousands of viewers. They don't know who I am, but I know who they are. Okay, so hopefully I'll have something prepared for the next time. And see you then.